In this problem, we're asked to find the spring constants K1 and K2 for two springs which are holding up some mass. In order to solve this problem, we need to know how to combine springs in parallel. The first thing to note is that the second spring has a spring constant that is double the spring constant of the first spring. The first step is to find the effective spring constant, which is the spring constant for a spring that is the same as if we were able to combine the springs with spring constant K1 and the spring with spring constant K2. Because these two springs are parallel, we combine their spring constants by just adding them together. So the effective spring constant is equal to K1 plus K2. K2 is equal to 2 times K1. Therefore, the effective spring constant is equal to 3 times the spring constant of spring 1. We can use Newton's second law in the y direction to solve for the effective spring constant. Nothing is moving when the mass is hung from the spring, so the y acceleration is equal to 0. The two forces acting in the system are the spring constant, which acts up, and gravity, which acts down. We can write the spring force as the effective spring constant times the distance that the spring has stretched. Solving this equation for the effective spring constant and rewriting it as 3 times the spring constant of the spring K1 with spring constant K1, we see that K1 is equal to mg divided by 3 times the stretched distance. Substituting in the numbers given in the problem statement, we find that K1 is equal to 10 newtons per meter squared, which means that K2 is equal to then 20 newtons per meter squared.